All right, so now this last example that we're going to look at is a, quote, working backwards problem. So what do we do if we've been given the probability associated with a sample and we're asked to find the mean that is associated with that probability? So here we're looking at the average height of an American male is 70 inches with a standard deviation of 3 inches. If we take a sample of 36 men, what mean height is in the 30th percentile? So I'm going to highlight or underline the important pieces of information. So the average height is 70 inches. The standard deviation is 3 inches. Taking a sample of 36 men, I'm being asked to find what mean height is in the 30th percentile. So remember, when we're told a percentile, that means the probability to the left, or the area to the left, is 0.3 or 30%. So then, just like I did when I found a probability associated with a sampling distribution, I am going to write down each of the numbers that I have here, and I'm going to identify what values those go with. Percentile. So the average height of an American male in the entire population is the mean of the population, mu. The standard deviation for all of those men is sigma. I'm taking a sample of 36, so my sample size is 36. And then my 30th percentile, that's giving me my probability. So I'm just going to shorthand that to probability. So then I do still need to know if I have a normal distribution, because if I don't, I cannot solve this problem with the methods that we have learned. So I need to either identify somewhere in the problem that says it's normally distributed, or I need to check and make sure that my sample size is larger than or equal to 30, and it is. So I do have a normal distribution, so I can continue on with this problem like I would if this were a problem where I was looking at an individual value and I was trying to solve for it. There's just one part that's going to be different. So the first thing we do is we draw our curve. That step was important enough to warrant its own step. So I draw my curve. Step 2 is I shade my curve. So the probability, the area to the left, is going to be equal to 0.3. So I'm going to start on the left, and I'm going to shade until I have shaded approximately 30% of my curve. Remember the line down the middle, marking my mean, that's cutting the curve in half, 50-50. So I can't go past that because then I would have colored 50% of my curve. I might go a little bit further actually. Maybe I would go to there. Doesn't have to be perfectly 30%, but I definitely shouldn't be going past the mean. So right here where I stopped coloring, there's some unknown z-score here. I need to then, in step 3, use Excel to go find that value. So we're going to find that value using norm.s.inverse. And the only thing we have to plug in is the area that is shaded to the left of the unknown z-score. So we shaded 30% or 0.3 of the total curve to the left. So 0.3 to the left corresponds with a z-score of negative 0.5244. And you can go ahead and round that z-score to 2 or 4 digits. I'm in the habit of rounding everything to 4 because I used to require all of my students to round every single number they gave me to 4. And I was being nice to you guys this semester, and I don't like that I did that. All right, so 0.5244 is our z-score. So now the last thing we're going to do is we're going to find x bar. So before, when we were looking for an individual person's score or an individual person's height, we would have been finding x. Now we're looking for what the mean height of a sample of 36 men would be at this particular percentile. So we're finding x bar. So to find x bar, when we're working in this situation, working backwards like this, it's z times sigma over the square root of n, the standard error, plus mu. So the z-score, that's what we get out of Excel in step 3. So if you are in the 30th percentile, you are a little more than half a standard deviation below the mean. Our sigma was 3. Our sample size was 36. And our mean was 70. So if I break this down just a little bit to make it easier to do this calculation, the square root of 36 is 6, and 3 divided by 6 is 1/2, or 0.5. Oops. Negative 0.5244 times 0.5 plus 70. So x bar, the sample mean that is in the 30th percentile, is 69.7378 inches. And that is our answer. So the only thing here that really changed once we saw that we had a normal distribution was the very last thing we had to do. We had to find x bar instead of finding x. Otherwise, these steps stay the same as they were if we were looking at an individual. So this is how you kind of work backwards, find the sample mean associated with a probability for a sampling distribution.